All right, well, what did you come up with on this one? Kind of it's a kind of a thing you could picture as being realistic. Yeah.
I mean, how much money do you make a month and how much are your bills?
Okay. Nice. I'll add those over here. So money per month. Income you're talking about, right? And then bills. Cool. So $360 bicycle, you could either pay what we call a down payment, which is common in bigger purchases like a house, cars, probably other recreational equipment that's expensive, that kind of thing. Sometimes I think people even pay down payments on trips, and like if it's a big one. Anyway, you pay a big chunk of it down, or at least a sizable amount down, and then you start paying payments on the remainder, versus just six equal payments over the course of the payment period. Do you have a feel for what's better just inherently, like just opinion? I'm asking you to just share what you think. He says down payment and smaller payments as you go, Jackson.
The 6 weeks.
Okay. So in this case, since it's $360, how much would each payment be over 6 weeks? Yeah, it would be $60. So I guess we're saying, would you rather pay $60 a week? And it doesn't tell us what a down payment would be, but let's say you paid $100 and then you had to pay the remaining $260 over this period, right? But I think Jeremiah's hitting on some good stuff. Like, what if you have bills and you can't afford that huge down payment initially? Or maybe your bills prevent you from paying the $60 a week, right? Maybe you've saved up money for this bike and you can pay that chunk down and it's easier to take care of the smaller monthly payments. Good. What were you going to say, Jack?
Or, like, you could also take into consideration, like, when she gets paid.
Okay.
Or how much money she already has.
Yeah.
Before the purchase.
Yeah, like, has she saved up? Good job. Now I'm going to shift your thinking to algebra. We know that we have to start at $360. What is that called from yesterday's work or from just what you knew from before? That's the y-intercept. Or we wrote in our notes yesterday, the y-intercept is the starting value in a story. So we started at paying $360 for one of these options. I'll explain what I mean. Which option is this?
Option B.
That is not evenly spaced. Let me do that again. Okay. So which option is that?
Option B.
That's option B. How do we know for sure? Yeah. Yeah, and so yesterday we started thinking of slope. So each of this, like the change in x, each time was 1 week. And how much was the change in y each time? Jackson actually said it a little bit. Yeah, so down or negative 60 each week. So our slope in that case would be what?
60 over 1.
But negative. Yeah, negative 60 over 1. That's our slope. It's going down evenly. How would we graph the second option?
We'd start at, if we paid $100 as the down payment, we'd start at 260.
Okay, so 260. Hi. Yeah, if we did 100, and it didn't say. Yeah, thanks. So we don't know for sure, but let's say it was 100. And then somebody calculate how much the payments would be. We'll assume that we have to pay it over 6 weeks still. It says at 2, by the way, to come there at 2. So we have 260 paid over the next 6 weeks. So it's not going to be a whole number. Grab your calculator.
43.3.
Okay, so 43.53. Is that what you said?
43.33.
Oh, 33. Okay.
Yeah, so 43 and 30.
Okay. So is that going to be a steeper line or a shallower line than the pink one?
Shallow.
Yeah, it's shallower, right? It's going to end up in the same place, but it's not as steep. That is not a straight line either, but that's okay. Okay, so we still have a 1 week X change. And then he said it's going down 40, what? 50. What was it?
43, or 43.
43.33. Okay, so you could save yourself $17 each week in terms of the difference there. All right, you guys see how this scenario relates to what we talked about yesterday?
Yeah.
Interesting, right? This is something you are going to have to, like, not will or maybe, it's going to be will have to consider someday. I assume probably everybody in here will buy a house. So you have, hey, can I put 50,000 down or can I only put 30,000 as a down payment? And then how does that change my payments going forward? Do you guys know the typical loan period for a house? How long it takes you to pay off a house?
Isn't it 2 years?
It's 30 years. A typical home loan is a term, you call it a term, is 30 years. And here's what's sad. If you choose to pay it off over 30 years, you end up paying hundreds of thousands of dollars of interest to the bank. It doesn't even go towards your ownership of the home. So this right here, how much you can put down in reality, like in real life, that can save you a ton of money if you can put a huger chunk down because you don't have to pay interest on as much money. So, side note there. Anybody taking personal finance yet? You'll learn this stuff there. It's cool. All right. Good connection to what we did yesterday, which was this stuff. Let's do a quick review. Grab your note packet so we can look at it. I threw a lot at you yesterday in terms of vocabulary, concepts. What did you say? Oh, was that you?
Huh?
Yeah, tell me about it. Did somebody say that? Okay, slope-intercept form. Y equals mx plus b. I want you to note that sometimes you will see this in a slightly modified version, which you probably know, but you might also see it with b first and mx second. So it might also be, I need to zoom out, hold on. There we go. It might also be b plus mx. It's the exact same thing. Oh my goodness, give me a break. So b plus mx. Anyway, x independent, y dependent. X is the one you get to choose. Often it's time. The y dependent is the one that responds to your choice. So I'm going to work 10 hours. They are going to pay me. That's their choice. All right, b in our equation, b is the y-intercept. It's where it crosses the y-axis, but also, like we just saw, it's the starting point for our work in a story. Keep in mind here that the coordinates for that are going to be 0 for the x, always, and then comma some number wherever we are on the y-axis. All right, slope. The ratio of the change in the vertical direction over the change in the horizontal direction. That was the definition of slope. And we wrote a couple different ways to look at it algebraically. Change in y over change in x can be summarized with deltas if you want. I'm totally fine with that. And then we finally ended up here with the slope formula that we can apply to anything. Here's what I mean. We can apply that to points, tables, or graphs, all three. So I want you to add that, please, because we're going to use it in all three. This works in tables, graphs, and from points, from just if I give you 2 points. We're going to need to be able to do that with all three. What was a good example from yesterday of how you experience slope probably every day? Do you guys remember? Oh, did I cut it off? What is the problem here? I think I'm still not zoomed out. There, finally I zoomed out all the way. Yesterday we talked about that, yeah. Stairs, right? You lift your foot through the change in y and you move your foot forward in the change in x. And those stairs actually are very closely related to slope. All right, so let's go look at those graphs from yesterday that you did. And that's not it. I got to find them. So give me a second to do that. There they are. All right, here they are. It does say to identify the slope and y-intercept. So in this first one, what's the slope?
1/2.
Yep. Slope. What's the 4? Yeah, I'm going to abbreviate that y-i, just because I don't want to write that a whole bunch of times. So remember, we start there. We put a point on the y-intercept. So we put a point at 4. And then how do we graph 1/2 as a slope?
Up 1/2.
Yeah, up 1, right 2. So from that blue point, up 1, over 2, we go to up to 5 and over to 2, and then do it again, up 1, over 2, up 1, and we just kind of repeat a pattern until you feel comfortable drawing your line through it. Yesterday we said how many points are needed to make a line? Just 2. If you have a straight edge, you can write a pretty good line through just 2 points. Next one. What's the slope? Slope. What's the y-intercept? -4. Yep, so we go put a point on -4. And how do we do our slope from there?
Up 3 over 1.
Yeah, so if you see a whole number, just know that it has a 1 underneath, so we can do 3 over 1. So this is up 3, right 1. Okay? So up 1, 2, 3 over 1. This is a steeper line. Up 1, 2, 3 over 1. That's probably enough. And there's our line. Okay, next one. What's the slope? 2/3. What's the y-intercept? There's not a number there. That means it's 0. Okay? So what? Yeah, that's the origin, this point right here in the middle. Okay, our slope. This time I'm going to use m since we learned that yesterday. So up 2, right 3. Up 2, right 3. There's a point. Up 2, right 3. Okay. Clearly not a straight line, but it's supposed to be. How'd it go? Those of you who did this last night, give me a thumb. We feeling okay with this kind of stuff? Okay. Basically, this is if you have the equation, you need to be able to graph it. A lot of our focus, though, is going to be writing that equation in the first place. For example, find the slope given 2 points. Let's pick one of these to take to an example in your notes. I'll take that one. So go to an example box if you want. Yeah. Let me write the title. So this is find the slope between 2 points. And we're given the 2 points there. If you get that problem written down in your weighting, do just off to the side, like maybe over here, do a quick sketch of where these points would be on a graph. Okay. So first step, I want you to visualize or sketch where these points are. And so in this case, again, sketch just means you're not graphing this perfectly. It's just giving you the idea. So 2, -1, where is that?
2 to the right, 1 down.
And then -4, 5.
4 left, 5 up.
Okay. So should we expect a negative or positive answer? Okay. I think we should that probably tells me we need to go write this in your notes, but that's a negative slope, downhill. Okay. So we'll write that after we're done putting this example in here. Okay, number 2. Write the slope. Actually, before we even do that, I want you to... This is going to be a little bit weird of a step. Pick 2 points. In this case, we're only given 2. But if I give you a table or a graph, you might have 10 points to pick from. So pick 2 points. That's step 2 for a general. Here we only have 2. Okay. Step 3. Write the slope formula. Which is what? Anybody know it without looking?
Y, who's that makes me?
That's the slope intercept formula. Just for slope.
And then plus we
M equals,
X.
all right, YB minus YA over XB minus XA. Okay. Good thing we're doing an example. All right, number 4. Plug in values carefully. I'm going to say this right here. It's helpful to identify YB, YA, XB, XA first. All you got to do is just go to either your table, your graph, or your points and just label them. It's super fast. And it's helpful to keep you from messing up plugging in stuff. Okay, here's what I mean. I'm just going to call this XA, YA. XB, YB. I have 2 points. Pick one and call it A, pick the other and call it B. It doesn't actually matter which is which. But make sure you label. Don't get these mixed up. Now we plug those into our formula. So YB is 5 minus YA. What do I write for YA? Do I just stick a 1 or do I need to write -1? Yeah, because the minus is part of the formula. This minus that's sitting here right now is part of the formula. In fact, let me make that just so it matches. Let's make that red minus -1. The -1 is YB. Okay, we'll do that down here too. XB is -4 and XA is 2. All right, then we just go ahead and calculate. So what's 5 minus -1? 6. What's -4 minus 2? -6. So what's our slope? Like simplify that.
-1.
-1. Okay. If you follow the steps I just gave you, you're going to be fine with this. People get mixed up when they're, let me point out some things. They call this 2x's, and they do like 2 minus -1 instead of jumping to the next point. They combine each point into one line. Okay, another place that people get these mixed up is flipping x and y over. Y is always on top. And then, of course, people mess up subtraction, just like we saw here. So be careful with that. Questions on finding slope from points? Now, the way I've given you these notes, you should be able to do this from tables and graphs as well. Okay? Why don't you do number, whatever that is. Just do the one I just circled. I'm going to give you 2 minutes. Jeremiah, can you take your hat off, please? Thanks. 2 minutes, slope between those 2 points. Pay attention in class. Good job. Is that what you asked, the first bold word?
Yeah, it says, she's like, I can't read that.
So just give yourself a quick sketch. In fact, like this one I'm going to do super quick. -4, -2 is down here, and -3, 5 is up there. So we should have a fairly steep slope and positive. Okay, I told you we're going to write that, but we'll do it here in just a second. So then go identify your XA, YA, XB, YB. Write your formula. Good grief. Fill in your numbers. Okay, YB is 5. And then YA is -2. And then XB is -3. And XA is -4. Okay, this one has all sorts of negatives. Hopefully you were careful with that. Here's what you should have gotten. 5 minus -2 is what?
7.
It's +7. -3 minus -4.
+1.
Yeah, so look 7 is a pretty steep slope on a typical graph. Okay? How'd you do? Raise your hand if you got it. Okay. If not, make sure you note where you got off on the wrong track there. Okay, notice the prompt. Find slope given 2 points. Like that makes it easy to pick your points. But sometimes we're given a table, etc. Before we move on, let's go add that little slope clarification to your note up here. I'm going to stick it just over here on the side. So this one, so we'll say uphill is positive slope. Can you see? Can you see? Uphill is positive slope. And then downhill, obviously negative, but we do need to clarify which direction we read a graph. Which is what? Which direction do we read a graph? Yeah. Read left to right.
Like a book.
It is actually just like a book. Well, a book in our country. I think some places read the other direction.
I think, Arabian or Arab. And I'm pretty sure in like the Middle East.
Guys, what is... Maybe, I don't know if we should put this here. I think we could probably do it later. But what's the slope of a horizontal line? If uphill is positive, downhill is negative, what's in the middle?
No solution.
No. If you think of a number line, positive, negative, what's in the middle of those two?
0.
0, okay? No steepness. A horizontal line, like walking along the floor, there's no steepness. It's 0 slope. Okay, we'll put that in at some point. But all right. I'm not sure we're quite there, actually. So here's what I want. This one, let's just see how you do with it. I'm going to write a table. You're welcome to do an example of this of it in your notes. I'm not going to actually put it in the notes just because we already did. Let's do that in a different color. Okay, so here's the table. Go ahead and find the slope, please, in that table. And read your notes that we just put, because the first 2 steps will help you, I think probably help you in this example. All right, let's check. Guys, in our notes, we said visualize. Listen up. Visualize was step 1 or sketch. You don't need to sketch all these points to see what's going on. Look what's happening with our y values. These are all going where? Okay, going up. That means our slope is going to be positive. I'm telling you that so when you solve, if you get a negative, you'll be like, shoot, that wasn't the right thing. Something went wrong. Okay, now he said pick 2 points. What is a point on here? Give me an example of a point. 2, 3. That is 1 point. It's two coordinates, but it's 1 point. Okay, so we could pick these 2, 2, 3, and 3, 5. Don't pack up, please. We'll finish up. We don't have to. We could pick any combination of 2. And we're going to say YB minus YA over XB minus XA. And we'll get 2. Note, if we had picked 2 different points. Don't talk, please. Let's say we pick these points way down here. YB minus YA over XB minus XA. We still get 2.